Hello, today's lesson is adding and subtracting polynomial expressions and polynomial functions. There are 5 things we want to discuss in this lesson. First, vocabulary. Second, adding and subtracting polynomials. Third, evaluating polynomial expressions. Fourth, recognizing quadratic and cubic functions. And lastly, finding the sum and difference of polynomial functions. For the vocabulary section, I'm going to list all the vocabulary words. Please pause the video and write down the vocabulary words. Okay, on to the next slide. Please take time to pause the video so you can jot down the vocabulary words. Good. Okay. Describing polynomials. Let's look at this polynomial expression. 3x squared plus 5x minus 4. First thing, if you look at the term 3x, it has a degree of 2. If you notice, out of the exponents that are on each term, the 2 is the biggest of all the exponents. So in this case, the exponent on this term is 2, the exponent on this term is 1, and actually the exponent on this term, which is hard to see, is actually 0. This is 4x to the 0 power. X to the 0 power equaling 1, so 4 times 1. So since this term has the biggest exponent, whatever that exponent is, that is my degree. So this is a second degree polynomial. And a second degree polynomial is known as a quadratic. Let's look at this situation. Slightly different. In this case, I have 1, 2, 3 terms. In this term, I have an exponent of 5 and 2 in this term. In this term, I have an exponent of 3 and 3. Well, in this term, I have an exponent of 1 and 2. So looking at the term that has the most variables in it will let me know what my degree is. So in this case, my degree is not just 5, but in this term, it's 5 plus my 2. So your degree actually looks at a term and decides how many variables are being multiplied together in that term. So the term that has the most variables being multiplied together will tell you what your degree is. So in this case, I have 5 A's and 2 B's. So this is a 7th degree polynomial. Now to add polynomials. Adding polynomials is just combining like terms. So for example, if you look here and notice that you have 5 a squares and then 2 a squares. So how many a squareds do I have? I have negative 7 ab's and negative 4 ab's. How many ab's do I have? And then I have 3 b squares and negative 9b squares, how many b squares do I have? So the first thing I want to do is I'm going to remove my parentheses because there's addition. I don't need parentheses. Remove my parentheses and then combine my like terms. So combine my 5a squared and my 2a squared, and so on and so on. So I have a total of 7a squares, a total of negative 11ab's, and a total of negative 6b squares. To subtract polynomials is also just combining like terms. So similarly to the last problem, I have 7x squares, and over here I have 6x squares. But I am subtracting this polynomial from this polynomial. So I would rewrite this as 7x squared minus 6x squared. Negative 2x minus negative 4x. 5 minus 1. So my first step is I represent that I am subtracting all of this. So I'm subtracting 6x squared, subtracting negative 4x, and then subtracting 1. And then I'm going to put my like terms together. So I'll do 7x squared minus my 6x squared. I'm going to convert this to addition. We see the plus here. I have 2x squared minus negative, which is the same as plus 4x. Then 5 minus 1. So first term, second term, third term. So now we're going to evaluate polynomial expressions. So given this polynomial, if I say f of x equals this expression, and I say, well, now x is going to be 4. So f of 4 says that x is 4. I take the 4 and plug it in everywhere I see an x. Make sure that you put parentheses just to ensure you don't make any careless mistakes. So as you plug in the 4 in for x, put parentheses. So in this case, negative 2 times 4 squared plus 5 times 4 plus 1. Order of operations says to do 4 squared first, and then times negative 2, and then 5 times 4, and then minus 1. For number 2, I'm going to plug in negative 3 in for my x here and here. And then order of operations, you do not do negative 2 times negative 3 first. You do negative 3 squared first, then times negative 2. And then if f of x equals 0, you take x out and you plug in 0. And that gives you negative 1. Now to find the sum and difference of a function. This is absolutely no different from adding or subtracting polynomials. Because we're looking at this expression and this expression. And so for example, if it says to find the sum of those two functions, I take this expression and add it to this expression. And this is just what we did earlier in this lesson. 5x squared plus negative 2x squared. Negative x plus 9x. 3 minus 7 If I said to evaluate this expression, the sum of the functions when x is 2, I would then take this numeric value for x2 and plug it into my result. And then simplify. Again, looking at these, but in this case, we're going to look at subtraction. Remember, there is no difference between adding and subtracting our expressions and adding and subtracting our functions. It's just one is an expression where the other is an equation. But keep in mind, I take this term minus this term. So that gives me 5x squared minus negative 2x squared, negative x minus 9x, 3 minus negative 7. And then we combine our like terms. Make sure you convert minus negative to addition and minus negative to addition. And I end up with this. Well, again, if I ask you to evaluate this when x is 2, you then take the value for x and plug it in for x. And f minus g of 2 equals 18. Now I just want you to understand what a quadratic graph looks like and a cubic graph looks like. So I'll graph these for you. I picked some points so you can see how the graph actually looks. So if I plot these points, I end up with this point, and so on, and so on. If you were to stop right here, it would appear to be a straight line almost. But as you continue to pick points, you will notice that your graph is not a line. It is what's called a parabola. All quadratic functions are parabolas. And a quadratic means it has an exponent of 2. The degree of the function is 2. For cubic functions, third degree, cubic functions, I'm going to pick some points as well. As I pick the points, you can see you have a slightly different looking graph. And this is the graph of all cubic functions. They may be wider or more narrow, or it may shift to the left, to the right, up, or down, but all cubic functions will have this basic shape. All right, please make sure you complete lessons 5.3 and 5.4 in my math lab. Thank you.